Good morning, my dear students. Welcome to the discussion on the subject Engineering Mechanics. Under this, we are discussing now a problem on equilibrium of bodies. This is the seventh solved problem we are discussing under equilibrium of bodies. Now we will enter into the problem. The given problem is a 300 kilonewton box is held at rest on smooth plane by a force P inclined at an angle theta with the plane as shown in figure. If theta is equal to 45 degrees, determine the value of P and normal pressure N exerted by the plane. Here, this is the box which is placed on the incline. In order to keep this box in a rest condition, we are applying a force P and this force is making an angle theta degrees with the incline, and this is the inclined surface, and we need to find the value of the applied force P in order to keep the box in a rest condition, and also we need to find the normal reaction exerted by the inclined surface onto the box. Here the weight of the box is given in the problem as 300 kilonewton and inclination given in the problem as 30 degrees. Now we will write the data. Here weight of the box is equal to 300 kilonewton and inclination with the ground is equal to 30 degrees. P is the applied force so that we can keep the box in a rest condition. That is the box in a equilibrium condition. Then force P's inclination with the incline is equal to 45 degrees. That is force P's inclination with the incline is equal to 45 degrees. N is the normal pressure exerted by the incline onto the box. Our objective is we need to find the value of the force P and N, that is normal pressure exerted by the incline onto the box. Now we will draw the free body diagram for this box. Here, as you know that the weight of the box is always acts vertically down and inclination with the horizontal is 30 degrees. P is the applied force which makes an angle theta degrees with the incline. As you know that the normal reaction is always perpendicular to the surface. So N is acting 90 degrees to this incline. That is normal reaction inclination with the incline is equal to 90 degrees. Here the inclination is 30 degrees and weight force is perpendicular to the ground. Then the weight force inclination with the incline is equal to 60 degrees. Then as the normal reaction inclination with the incline is 90 degrees, then the angle between normal reaction and the weight force is how much? That we'll see now. Here our objective is to find the angle between weight force and normal reaction. Here the normal reaction is making an angle 90 degrees to the incline, whereas weight force inclination with the incline is 60 degrees. Then this angle becomes 90 minus 60, which is equal to 30 degrees. If it is 30, then this angle becomes 30 degrees. Here this is the weight force. This inclination with the incline is theta degrees. Weight force is perpendicular to the ground, 90 degrees, and it is 60 degrees. The normal reaction, N. This total inclination of the incline with the incline is 90 degrees. If it is 60 degrees, this angle becomes 30 degrees. Then this angle becomes 30 degrees. That is the angle between normal reaction extension force and the weight force is 30 degrees. Now we will resolve the weight force along the incline as well as normal to the incline. Here this is the direction of the force along the incline and this is the direction of the force normal to the incline. The direction of force along the incline is x and directional force normal to the incline is y. Now our objective is to resolve the weight force as well as applied force along the incline as well as normal to the incline. The weight force along the incline is equal to W sine 30 degrees and weight force normal to the incline is equal to W cos 30 degrees. Now we'll resolve the applied force P. Here the applied force is making an angle theta degrees with the incline. Then the force along the incline is equal to P cos theta and the force normal to the incline is equal to P sin theta. Here theta value is equal to 45 degrees. Now we consider the equilibrium condition of this block in order to calculate the applied force P as well as normal pressure exerted by the incline onto the box. Make a note. In the problem it is mentioned that the inclined surface is smooth. With that, we are not considering the frictional force between box as well as incline. Now we will consider the equilibrium of the box. Here we are considering summation of the forces along the incline is equal to 0, that is sigma f of x is equal to 0, and summation of the forces normal to the incline is equal to 0, that is sigma f of y is equal to 0. Here rightward forces we are considering as positive, leftward forces we are considering it as negative. Upward forces we are considering it as positive, downward forces we are considering it as negative. First we will consider the first condition, that is sigma f of x is equal to 0, that is summation of the forces along the incline, that is sigma f of x is equal to 0. Here 300 sin 30 degrees is leftward direction force, that's why it is negative. P cos 45 degrees is rightward direction force, that's why it is positive. So sigma f of x is equal to minus 300 sin 30 degrees plus P cos 45 degrees is equal to 0. After simplifying this, we will get P cos 45 degrees is equal to 300 sin 30 degrees. P cos 45 degrees is equal to 150. Then P is equal to 150 by cos 45 degrees, which is equal to 212.13 kilonewton. Now we'll consider the summation of the forces normal to the incline is equal to 0. Here normal reaction 300 cos 30 degrees, P sin 45 degrees. These three are the forces normal to the incline. Then summation of the forces normal to the incline is equal to 0, that is sigma f of y is equal to 0. Here upward forces as positive, downward forces as negative. Here normal reaction is upward force, 300 cos 30 degrees and P sin 45 degrees are downward. That's why n is positive, 300 cos 30 degrees and P sin 45 degrees are negative. Then sigma f of y is equal to n minus 300 cos 30 degrees minus P sin 45 degrees is equal to 0. After that, we'll substitute P value in this equation. P is equal to 212.13 kilonewton. Then n is equal to 300 cos 30 degrees plus P sin 45 degrees, which is equal to 300 cos 30 degrees plus 212.13 sin 45 degrees. After simplifying this, we will get 259.81 plus 150, which is equal to 409.81 kilonewton. That is normal pressure exerted by the incline onto the box is equal to 409.81 kilonewton. Now we will write the answers. Normal pressure exerted by the smooth inclined surface on box, that is N is equal to 409.81 kilonewton, and applied force on the box, that is P is equal to 212.13 kilonewton. With the applied force P is equal to 212.13 kilonewton, we are keeping the box in a rest condition on the smooth incline. If you have any doubts or queries, to write it down below comment section. I will be very happy to answer it. Visit again for more videos on engineering mechanics using the links provided under the description of this video. Keep learning and knowledge sharing. Stay blessed. Thank you.